This is section 8.1, and we're going to be looking at graphing functions that are in the form of f of x equals a times x squared. Everything that we've graphed up until now has been linear, means it makes a straight line. And so we're going to look at a different type of graph and see what happens when we square the variable that's in our function. The first thing that we want to talk about is how we identify the characteristics of a quadratic function and what it is. So a quadratic function is a nonlinear function, meaning it doesn't make a straight line, that can be written in the standard form y equals ax squared plus bx plus c, where a is not equal to 0. Hopefully this looks kind of familiar to you because ax squared plus bx plus c is exactly what we've been working on factoring for the last week or so. When we graph this function, and we've kind of seen this before on different examples, the graph is going to be kind of a U-shaped graph, and that is called a parabola. So here is an example of what a parabola would look like. The parent function, remember we've talked about the parent function is the most simple basic function for this particular family. So the parent function for this one is f of x equals x squared. That's the one that we compare all of the others to. So every other graph of a quadratic is some sort of transformation from that. Transformations are things like making it wider, making it skinnier, moving it up, moving it left, moving it right. Those are all examples of transformations, okay? So that U shape is either going to open up or it's going to be an upside down U. And the very, very bottom, or if it's upside down, the very, very top is called the vertex. And so right here would be the example of where the vertex is in this particular graph. The vertex is 1 point. So if we were talking about this graph, that's right at 0, 0. Okay? Another important thing is called the axis of symmetry. And that's the line. You'll notice that if I were to fold this parabola in half over this dotted line right here, it would match up exactly. It's symmetric over that line. So anything that happens on the blue side also happens on the red side just as a reflection. And so that axis of symmetry is really helpful. The axis of symmetry is always an equation since it describes a line. This example here, since it goes through 0, 0, would be the vertical line x equals 0. That's our axis of symmetry, okay? Other important characteristics of a parabola are whether it's increasing or decreasing. So in this particular example, you can see that on the left, the red side, it's decreasing to move towards the vertex. We always decide this by reading the graph from left to right, just like you would read a sentence. So if we start at the left side of the graph, we see the graph is moving downward until we get to the vertex, and then it changes direction, and as I continue on to the right, it starts to move upward. So it's increasing on the right side of the vertex, decreasing on the left. And another thing that is important is the domain and the range. Remember that the domain describes all possible x values. In this particular example, since we look at the arrows and we see that we have one that points to the left and one that points to the right, the domain is all real numbers. You can plug in any possible number that you want. But if we look at the range is the possible y values. You see that it starts to come down, but then it turns around and goes back up the other way. So we're not going to get any points underneath that vertex. Since the vertex is at 0, the range would be y values that are greater than or equal to 0. And so when we want to look at the important characteristics of a parabola, there are always 6 things. So the vertex, the axis of symmetry, the domain, the range, and then where it's increasing and where it's decreasing. So those would be the things we always want to look for. Here's an example. What they want us to do is identify the important characteristics of the quadratic function and its graph. So we're looking at this blue parabola right here. So here are the 6 things that we want to identify. And the first one is the vertex. The vertex would be this very bottommost point right here. And if we look at our graph, you notice that this is counting by 2s. So you have to watch for that. So this ordered pair would be 2, negative 4. And so that's the vertex, 2, negative 4. The axis of symmetry is this imaginary line that comes down right through the vertex. Since the vertex goes through 2, it will be x equals 2. One thing that I want you to notice is that the x value from the vertex is always going to be what our x is equal to for the axis of symmetry. The domain, again, look at our arrows. They go to the left and to the right, so the domain is going to be all real numbers. And then the range, we see that it starts at the vertex, and then our arrows go up from there. And so this is going to be y values that are greater than or equal to our lowest point, which is negative 4. If we want to know where it is increasing to the right of the vertex and decreasing to the left of the vertex. And the way we describe where it is increasing and decreasing is based off of looking at the x-axis like you would a number line. So let me erase some of this stuff I've scribbled on here. We see that right here is where the vertex goes. On this side it increases, and on this side it decreases. This is at 2. So I'm going to say it's increasing where x's are greater than 2, and it's decreasing, whoops, I'm sorry, this should still be x's. It's decreasing where x is less than 2. Now, why did I use less than and not less than or equal to? Since the vertex is just 1 point, it's not increasing or decreasing at the vertex. So it's only increasing when I step off of the vertex. It's only decreasing when I step off of the vertex. That's why we're not including 2 in those points. Go ahead and pause this and see if you can come up with the 6 things for this next one. Think of this as a quick little self-quiz to see if you understand how to figure this out. And if you don't, then make sure that you ask one of the teachers so that you can figure out what you need to do. After you pause this and work this out, then come on back to me. So what you should have is that the vertex is this point right here. This graph is counting by ones, so the vertex is at negative 3, positive 7. The axis of symmetry is x equals negative 3, because again, that was the x from our vertex. The domain is all real numbers. We're going forever left and right. But the range, since this parabola is pointing down, the highest point is 7, and then it's all the points that are less than or equal to 7. Then for increasing and decreasing, we go back to our x-axis. And if you notice, we drop down the vertex. It's right here at 3. So when x is less than 3, it is increasing. And when x is greater than 3, it is decreasing. Notice that that's backwards. Since this parabola is upside down, remember we read it from left to right. So if I'm going from left to right, this is now increasing, and this side is now decreasing. That's backwards from the example we looked at before. Okay. So let's talk then about how we would graph these. All we're going to do is make a table, and we want to compare this to the graph of f of x equals x squared. So let's go ahead first and make our table for y equals 2x squared. And notice that, as I mentioned on the top, we want to always use the values negative 2, negative 1, 0, 1, and 2. Go ahead and plug in those same ones every time. So negative 2 squared, remember that any number squared makes a positive. And what you also have to remember is that with our order of operations, we do exponents first and then we multiply. So first I'm going to do negative 2 squared, and that's positive 4. And then I have to multiply that by 2, so I get 8. Negative 1 squared is 1. Then I multiply, that gives me 2. 0 squared is 0. and 2 times 0 is just 0. Then we have 2 times positive 1 squared, which again is 2 times 1, so we get 2. And then 2 times positive 2 squared, which is going to be 2 times 4, which again is 8. Always have to remember that exponents come before multiplication. So let's go ahead and graph these ordered pairs. -2, 8, -1, 2, 0, 0. This isn't drawing for some reason. There we go. 1, 2, and 2, 8. So this is, we connect this with a smooth curve that's going to make a U shape. It's kind of steep. So this is what that's going to look like. Now they also want us to compare this to the graph of f of x equals x squared. So for that, we're going to need to make another table. So I'm going to do it up here at the top. -2, -1, 0, 1, and 2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So let's plot those points. We have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So we see that this parabola looks like this. This blue one is f of x equals x squared. So they want us to compare those two. So how is the red one different from the blue one? The g of x is narrower than f of x. And that's really all we need to say, because that's really all that's different about it. The vertex stayed the same, the axis of symmetry stayed the same, even the domain and range stayed the same, but it just got skinnier than the blue one. Okay? Let's look at another example. Again, we are going to plug in the exact same numbers. -2, -1, 0, 1, and 2. So I'm going to plug those in. We want to do 1/2 times -2 to the second power. Exponents first, so we get 4. Half of 4 is 2. 1/2 times -1 squared is equal to 1/2 times positive 1, which is 1/2. If I plug in 0, I'm going to get 0. Then we have 1/2 times positive 1 squared, which is 1/2 times 1, again 1/2, and 1/2 times 2 squared, which is 1/2 times 4, which again is positive 2. Do you notice that it starts to follow a pattern? It always goes down to 0 and then comes back up the same way. That's always going to happen. So -2, positive 2, -1, 1/2, 0, 0, 1, whoops, 1, 1/2, and 2, 2 again. So here is our red parabola. And then look back at the table that we did for the first one just a second ago, and you can get your table again for f of x equals x squared. That was -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. It looks like this. So now, how is the red one different from the blue one? This one we see that g of x is wider than f of x. Okay? So I have one more for you. Go ahead and try this one on your own. And then I want you to come back and check your answer. So go ahead and put me on pause real fast. Here is what you should get for your table. You should get -2, whoops, -2, -12, -1, -3, 0, 0, or sorry, yep, that's right. 1, negative 3, and 2, negative 12. Now, those are going to be a little bit off our graph, and that's okay. So watch what happens. Negative 2, negative 12 is going to be somewhere down here. Negative 1, negative 3, 0, 0, 1, negative 3, and 2, negative 12. So here's my graph. And then again, if we graph that same table that we keep doing over and over again, we're going to see one that looks like this. So how is the red one different from the blue one? Well, this time, like I said, two different things has happened. One, g of x is upside down. And what we call this is a reflection. Whoops, I'm out of space here. Reflection. And it's also narrower or skinnier, however you want to think about that. Okay, so that's all we're working on today. Make your tables, graph them, and that's what we're going to look at. Good luck.